Hi everyone, and thanks very much for joining this Google Hangout live on air to introduce the IoT Starter Kit from ARM and IBM. We've got Shelby from ARM on the Hangout. We've also got Locke from IBM and Jas Gohlar from Element 14. I'm going to hand over shortly to Jas to run through a few of the features on the board. But what I want to just point out first is that we've enabled the Q&A app. So if you've got any questions as we're going along, please feel free to ask those. I'm actually just going to read out the instructions from the invite that I set up, just because we've had problems with this previously. So you have to be on Google Plus to use the Q&A function. You can't do this from YouTube. And basically what you will do is down the right-hand side of the Hangout on Air, you'll see you can see the option. The bottom right-hand corner of the viewing window, you need to click Ask a New Question. You type in your question and you click Submit. That will come through to all of us, and I will ask the question and one of us will answer it. So it'd be great if you could ask some questions. Otherwise, not to worry. So great. So we'll make a start, and I will hand over to Jas now.
Thanks, Jen. I'm Jas Gohlar. I work for Element 14 as a technical development manager. I hope you can hear me clearly. So today, we're introducing this IoT kit. Premier Farnell, Element 14, was fortunate enough to take it on board and bring it to the market. And today, we are the only people who can support this rather innovative tool. And it turns out to be very, very popular right now because we're selling out quite quickly. But just to quickly give you highlights of it, today you'll find this tool available for sale in the UK for £79 or $119. As we all may be very aware that IoT has really taken a very high, shall we say, interest in the marketplace. I mean, if there were some surveys run on it, it kind of showed that about 40% globally people are very keen to connect IoT-wise. And if the same sort of survey was run in India and China, you'd find something like 70% of people actually hooking up. And already there's some significant numbers which suggest today nearly 10 billion IoT connectivities are active. And the suggestion is something like 50 billion would be in the next coming few years. And we're talking about applications where these things will be cited in smart cities, businesses, homes, and wearables as well, with specifics like smart metering, assisted living, building automation, traffic management, for instance. And that's just to name a few. But the whole point here really is to be able to share info surrounding the environment, if you like, where you can realize the potential of the information that you're collecting, and then obviously use those models for the purposes of efficiencies and productivity, if you like. And all of this is enabled with the cloud services, which Dave will talk about in a few minutes. So, in effect, really, how does this ARM Embed IoT Starter Kit, how can it be utilized? Well, the IoT kit enables users to make IoT products that are cloud ready, transmitting and receiving data for analysis purposes, and obviously resulting in some sort of resultant productivity-wise or some positive outcome from it. And when you look at the actual tool, which will be shown shortly, there is a sensor board, for example, on it. That's exactly one illustration of the sort of things that you can pick up from IoT point of view. Ultimately, users can extend features and examples beyond that. And Dave shortly will also be explaining where you can find the recipes, which will guide you through various other examples. And within there, obviously, there are a number of menus that you can port. Now, today, when we sell these things, they have this form. So you send them up here like that. And inside, just to kind of explain what's contained, I've got one which, by the way, is already open, so rather than trying to pull this one out, there is one which, unfortunately, I'll have to drag it. Kind of looks like this, which is already fired up, connected and working right now. And so that's what you get, plus a USB kit with it. But equally, to just make things easier, you do also get a leaflet which explains how to connect it all up, which is all posted anyway with a few do's and don'ts at the back. And I think from that general brief introduction, I'll pass it over to Zach.
Hi everyone, my name is Zach Shelby and I'm the VP of Marketing for IoT at ARM. And I'm going to tell you a little bit more about the hardware that we're providing in this kit and the software ecosystem that we provide so that you can make applications for an IoT device and then hook it up to the cloud. And then soon Dave Locke, my colleague from IBM, will run you through a demonstration of how that actually works. How can we unbox this device and get it hooked up to an actual cloud service, and you can prototype your idea. So this IoT Starter Kit is actually a combination of two boards. We have what we call a motherboard, which contains a Cortex-M4 low-power microcontroller from ARM Silicon Partner Freescale. So this is a pretty powerful device, 32-bit. You can do security, internet communications, and a lot of sensor processing. That board is easy to use in the sense that we have a USB connector, and that USB connector can be used for debugging purposes, for power, as well as for actually programming the device. And so this is your programming interface at the same time. So we've made programming very easy. The board that goes on top is what we call a shield. And this shield that we include with the IBM IoT Starter Kit contains some pretty neat components on it, including a screen for input or output to the user, as well as joysticks, buttons, and most importantly, a few sensors. So we have temperature sensor on board, a 3-axis accelerometer as well. So you can do some interactive applications with the device. Now, of course, for an internet-connected device, we need connectivity. And this particular kit is Ethernet based, and we find Ethernet to be very easy to get up and running with and started, and easily hook up to the internet and to the IBM cloud. In the future, we're looking at possibly producing other kits with different kinds of communications. So look forward to that in the future. Now, an important part of this kit is not only that we can connect the device to the cloud, but we can actually develop on the device itself. And we do that using what we call the Embed IoT Device Platform. So this is a software ecosystem of online tools, offline SDKs, and the actual software that runs on the device that we provide you from ARM and ARM partners. And what you're running on this device is something called the Embed SDK. The Embed SDK provides basic operating system functionality, IP stacks, protocols such as MQTT that we use in this kit setup, and a very nice development environment. So the kit is up and running with an example application out of the box, and then it's very easy to get up and using our web development IDE and make modifications to that kit. So just because it's doing something to start with doesn't mean you can't easily modify that. With that, I'm going to hand off to Dave, who's going to run us through an actual demonstration with the kit.
Many thanks, Zach. Yeah, so just a brief introduction, a little bit of background on the kit. So one of the goals we had when IBM started working with ARM was to make sure we could actually make it very, very simple to connect devices from tiny little embedded sensors all the way through gateways across the wide area network into the cloud. So what we're predominantly trying to do is make that connectivity very simple so that then the embedded developer or the maker can concentrate on building out the device side, and the application developer on the cloud can concentrate on building out the application side on in the cloud, with the connectivity almost being given for free, so you don't have to worry about how to do that. And that's sort of the background to the starter kit. And we actually set a design goal that we wanted the maker to be able to take the kit out of the box, plumb the two pieces together, so the shield and the main board with the Cortex-M4 processor on it, connect it to the network, in this case plug in the Ethernet cable, plug in the power via the USB, get data flowing from the sensors into the cloud, and to visualize that data in the time it takes to drink 2 beers. And we pretty much think we've done that. So I've actually, just in the interests of time here, actually got a working kit already plumbed together. And unfortunately, the cables aren't really long enough, with the baseboard, the application shield, Ethernet plugged in, and the power. And you'll see the actual LED light is green. So literally, as soon as you plug the power in, there is a starter application on the board that starts reading the sensor data that Zach was talking about and publishes that using open protocols across the wide area network up into the cloud. Now, one of the things that happens when you plug in the USB cable is it makes the device, as well as giving it power, it makes the device look like a mass storage device, a USB key. So what I'm now going to do, I'm going to switch across to the screen share so you can actually see what's happening live in the demo. So let me switch across to my screen. And hopefully now you can see the file explorer, and you will see over here an embed file system showing up. So that's the device making itself look like a file system. And within there, there's a URL, ibm.htm. If I select that URL, it opens up a web application that basically is now saying, give me the data that's coming from that device. What's actually happening here now is the data is flowing from the device across the internet to IBM's cloud data center. In this case, it happens to be running in Dallas, into a service called the Internet of Things Foundation service. Built into that is a simple web application to visualize the data in near real time. So when I clicked on that URL, it's opened up the visualization app, and you should be able to see the data coming live back from Dallas into my web browser over here in the UK. And just to show there's no smoke and mirrors, if I select potentiometer 1, by default the visualization doesn't know what the type of data is, so it doesn't know how to scale it. So now I'm going to take the potentiometer around all the way clockwise and go back all the way anti-clockwise, so it'll basically now calibrate it between 0 and 1. And as I turn it, you should see the data actually changing. So that's sort of the 2 beers use case, actually getting it connected to the network, data flowing, and to visualize it. So as Zach said, there's now the focus is now, let's make it really simple to build out applications that use the starter kit both on the device side. So that's where ARM and that embed tooling and the embed ecosystem really comes into its own. That makes it very simple to build applications to go on the device. And from an IBM side, we've got the equivalent to embed, and it's called Bluemix. It's a platform as a service that makes it really simple for cloud developers to build out the server half of the application. So very quickly, I'll run through Bluemix, and I'll build an application live that uses the data coming from the device. So Bluemix enables you to write applications in whatever your favorite runtime is. So if you look at the catalog here of runtimes, by default you get Java, JavaScript via Node.js, Go, PHP, Python, Ruby, and because it's all built on open standards, open source, in this case it's built on Cloud Foundry, you can actually bring your own programming runtime into Bluemix. And then the idea within Bluemix is you really compose applications, and you compose them out of a set of services that you will see in a catalog. The services range from cognitive analytics with Watson, so you can see some Watson services here, anything from text to speech, speech to text, cognitive commerce, there's all sorts of interesting things. Going through mobile, so push notification. As I'm going through here, you'll probably see services from IBM. So IBM have got their own services. There's also third-party services from popular companies like Twilio, which enable you to send notifications to mobile phones. Scrolling on down through, all the sorts of things you'd expect. There's web application, caching, gamification, messaging. Many types of data store, from NoSQL, SQL, big data, there's time series data, and then actually the one we're really going to focus really on today is at the bottom down here is the Internet of Things service. So Internet of Things Foundation is the service that receives and that acts as the gateway for the device. So basically the starter kit connects to the Internet of Things service, and from there we can actually do things with the data coming from that device. Now, to make it simple to get started, ARM and IBM have put together a device connectivity recipe that tells you how to get started with the device, to plumb it together, and how to build your first IoT application live. So just briefly scrolling through, you see what we've already done, connected it and visualized the data. Now we're going to actually build up an application using services in Bluemix to actually utilize that data. And what I'll be doing is actually getting the device to actually tweet. Now, to do that, we're going to use a pre-built application, a JavaScript application called NodeRED. NodeRED basically means I can actually build powerful IoT applications without writing any code. I can actually do it via a visual wiring metaphor. So to do that, you basically go into the NodeRED into the Bluemix catalog, select the Internet of Things Foundation boilerplate, and that creates me a starter application, which you can see in my dashboard of applications. So that I've got 5 applications on here, ranging from Embed IoT app down to Starter Kit. So today I'm going to use the Starter Kit application. At the top here, you can see it's basically using a Node.js runtime. The NodeRED application actually basically creates is used to author Node.js applications using this visual wiring metaphor. And you'll see it's going to use the Cloud Ant NoSQL database. So you simply click on the root at the top here to open up the NodeRED editor. And here on the screen now, let me expand to full screen, you'll see I've got an empty canvas to create the application in. On the left-hand side, there are a series of nodes. So we've got input nodes at the top, so we've got standard nodes like HTTP, MQTT. We've got a customized node, which is the IoT node, which is really an MQTT node. There are many output nodes from TCP, UDP, push notification, functional nodes, social nodes for tweeting and email, different types of storage nodes from HDFS, Cloud Ant, even things like sentiment analysis. This is all open source, so anybody can contribute to it. So the set of nodes on the left-hand side are just a subset of the nodes that are available. There are many nodes, including nodes that run on devices to control things like Philips Hue light sources and Ocean devices, Raspberry Pi nodes, etc. Except in this case, we're running NodeRED in the cloud, so the pure serial type connectivity to devices isn't possible here. That's when you would run NodeRED on an actual end device. So what we're going to do, very briefly, I'm going to select a couple of the nodes here. The first one is the IBM IoT input node. And we're going to use the Quick Start service. This is a public IoT service that the device is currently connected to. And all I need to do in order to receive data is give the unique identifier of this starter kit. So if I go back to the visualization page, we'll see in the URL the unique identifier, which is basically the MAC address of the device. We're going to cut and paste that into NodeRED and save it. And as with all good programming examples, we want to make sure it's working, so we're going to bang a debug node out. We'll wire the output of the IoT input node, which is basically the raw data coming from the device, into the debug node, and we're going to deploy it. And if we got it right, you'll see on the right-hand side of the screen, the raw data is now coming from the device in JSON format, and it's being published every second. So let's quickly actually make use of some of that data. What we'll do, we'll take the value of the potentiometer, and we'll basically cause it to tweet when the value is greater than 0.5. So the first thing we'll do is we'll inject a function node, which enables us to put a little bit to inject real code. So sometimes you don't have a node to do what you want, so we enable you to write code within NodeRED. So we'll open this up, and I'll just quickly cut and paste the code, which extracts the value of potentiometer 1 from the JSON. So it's a single line which returns the value of potentiometer 1. Then we'll add in a switch or a select statement, which enables us to choose what particular values we want. So I'm going to say if the value is less than 0.5, we're going to go out output 1, oops, and if it's greater or equal to 0.5, we're going to go out of output 2. So the end of the switch node, you can see two outputs. The first one will be if the value of the potentiometer is less than 0.5, the bottom one if it's greater than 0.5. So in this, what we'll do now is going to say if it's greater than 0.5, we want to tweet. So first we need to decide what the message is we're going to tweet. So let's create a message. Message.payload equals hi Google Hangout. And just because Twitter doesn't like us sending the same message twice, we'll actually put a date on just to show there's no smoke and mirrors with me building this application. So we've got message payload equals hi Google Hangout, got the semicolon on the end, good. And now we'll configure a Twitter output node, which is in the social block. Wire that up. And we need to tell it which Twitter node to go to. So I've got one called IoT Automate, which if anyone wants to follow it, they'll very shortly, hopefully, see us tweeting based on an event coming from the device. We're also adding one last node, which is another debug node, just to make sure that's actually what's really occurring. To make this application live, literally all we do is hit the deploy button, and NodeRED in effect generates the JavaScript application that is deployed into the Node.js runtime in the Bluemix cloud running in our Dallas data center, our Dallas Cloud data center. So now we'll deploy that, we'll turn off the original debug, clear it, and I've got the potentiometer currently set to go right round to the left, so it's less than 0.5. As I rotate it round, if I've built my application right, we should now see we're actually sending a message, hi Google Hangout, into the debug console. Let me turn it back round before I use my tweet allocation up, and I'll go across to the Twitter account over here, and if I refresh it, there we go. We've now got the device as basically we played around with the potentiometer on the device in sending data in real time into the cloud. We've built the application to receive the values coming from the potentiometer and to send the message, hi Google Hangout, with a date stamp when the value is greater than 0.5. So as well as getting the device connected in the time it takes to drink 2 beers, we've basically created my first IoT application in the time it takes to drink 2 beers, or if you're in Ireland, maybe the time it takes to drink one Guinness. So again, really what the value we've been trying to do between ARM and IBM is first of all make that connectivity really, really simple, but then to actually make it even just as simple to start building out the actual application, so the solution that you're trying to build. So I guess I'll hand it back to Jen at that point in time, and I guess we might be going for questions.
I think that was brilliant. I actually just jumped onto Twitter then as well to see if I could see that tweet appear, and it did. So yeah, that was great. So thanks very much. Are there any questions at all from anyone? I'm looking at a blank questions page at the moment, unfortunately, but I'll just give people a chance if they want to ask any questions. Obviously, the recording of the Hangout will be available on YouTube, so you can watch it back. You can pause it, because I know that Dave rattled through quite a bit there, so I'm sure there's things that you want to revisit potentially and watch again. So just offering up, I need to be quick because I'm going to close the Hangout shortly. So no, with that, no questions. So thanks very much again to Zach, Jas, and Dave. Any more from you guys at all that you wanted to add at this stage? Nope, I'll take silence as no.
Oh, so Jen, the only thing I'll do is I'll paste in the links to things like the recipe. So like the IoT application I created live in front of you. We've actually got a very nice guide that walks you through how to do what I actually showed you live. So I'll send the links and you can add that to the video.
That's brilliant. Thanks, Dave. Yeah, that'd be really helpful. So I'll add all those links to the video description. And I guess for more information or to buy the product, you can visit the Design Center on the Element 14 community at element14.com. So with that, I'll close the Hangout. Thanks again, everybody. Thanks for watching if you did, and we'll see you soon. Thanks very much. Bye.
Cheers all.